Hello everybody, here's our video on prerequisite skills for vectors. These are just some reminders about working with triangular trigonometry. So remember a couple of things you should have in your toolbox, remembering that for a right angle triangle, a squared plus b squared equals c squared. That's our Pythagorean theorem. And we know the sine, cosine, and tangent ratios for a right angle triangle. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's our SOHCAHTOA. Okay, so we need to know that to help us out sometimes in our vectors questions. Sometimes we have a triangle that's not a right triangle, and then we need to use either the sine law or the cosine law. And those can be used with any triangle. But only in certain situations. So, for example, we can use the sine law when we know at least one angle and side pair. So notice here that to use the sine law, we label the triangle with angles in capital letters and sides in lowercase letters, and that angle A is always opposite from side A. Angle B is opposite from side B, and angle C is opposite from side C. So if I want to use the sine law, I need to fill in at least one of these fractions, which means I need to know at least one angle and the side opposite from it. For cosine law, I can use the cosine law if I don't know any of the angles in the triangle and I'm trying to find the angle. So that would be this second version here. I know all the side lengths, but no angle, or I know two side lengths and an enclosed angle. In this case, for this version of the sine law, this version of the cosine law, I'd have to know angle A and side lengths B and C, and I could use it to solve for side length A. The last thing we need to know is about solving a triangle. So when we say solve a triangle, we mean to find the measures of all the sides and all the angles whose values are not given. And to solve a triangle, we need to use all of those tools we just talked about: trig ratios, Pythagorean theorem, sine law, and cosine law. Okay, that was an Amber Alert. So the other thing we should be able to do is state exact values for trig ratios. And we've done a little bit of practice of that with...
Good morning, staff and students. Please pardon the following interruption.
Okay, so we should be able to state exact values, and we might need to use our special triangles. Just keep in mind, in this picture, I used it because they used degrees for the angles instead of radians. When we're dealing with vectors, we deal with degrees instead of radians usually. But they wrote this as root 2 over 2, and remember that that's the same as, the same as just root 2. Okay. And same thing here. This is the same as, they wrote it, never mind. This is the same as 1 over root 2, I should say. Okay, and this is the same as 1 over root 2. So if I want to know the sine of 60, for example, I'm going to find 60 on my special triangles. Sine is opposite over hypotenuse. So sine of 60 is root 3 over 2 over 1, or just root 3 over 2. Cosine of 60 would be adjacent over hypotenuse. So in this case, cosine of 60 would be 1/2. Okay, 1/2 divided by 1, or just 1/2. And sine of 135, we'd have to think about our cast rule. Well, sort of. We need to think about our angle rotating into the next quadrant. So 135 is going to fall over here. This is 135 degrees. This is 45 degrees, which is its reference angle. And that makes a triangle, a special triangle here with sides 1, 1, and square root 2. So sine of 135 is the same as sine for this angle 45, sine of the reference angle, which is 1 over root 2, but it is in